Welcome back, children. So first of all, I would like to give you the definition of a solution. A solution is a mixture in which the constituents are spread uniformly throughout the entire mass of the solution. Means a solution will be called as a homogeneous solution. So such type of solution which is called as a homogeneous solution, that is called as a true solution. Other types of solution. Now first of all, what is a solution made of? I told you a solution is made up of solute and solvent. This solute is the solid part, solvent is the liquid part. Now if the liquid part is water, then it is called as aqueous solution. And if this liquid part is anything other than water, then it is called as non-aqueous solution. Clear? Now generally, when a solution is there and the solid and the liquid parts cannot be distinguished from each other separately, then that solution is called as a true solution. Right? Supposing you make a solution of sugar and water. You mix 2 spoons of sugar in water, stir it nicely, the sugar gets dissolved. After the sugar gets dissolved, can you separate or can you look, can you identify the sugar particles from the water particles separately even by using a microscope? No. So that type of solution is called as a true solution. It is 100% homogeneous, means the sugar particles gets uniformly spread throughout the entire mass of the solution in such a way that you cannot identify sugar particles and water particles separately. So such type of solution is called as a true solution. Similarly, salt solution is also true solution. One salt gets salt, means salt will be the solute and water is the solvent. So in case of salt solution also, that is a true solution, because once salt gets dissolved in the solvent water, you cannot identify salt particles from water particles separately. So again, salt solution is an example of a true solution. So children, next we come to the properties of a solution. I have written these properties. If you want, you can write them down. First is, a solution is clear and transparent. Now if you prepare a salt solution or a sugar solution, you will find it is clear and transparent. Means it will allow light to pass through it easily. That means transparent, just like plain glass. A solution is stable in nature. Now what does this mean? This means that after you have prepared a salt solution or a sugar solution and you have kept it for few hours without disturbing it, undisturbed, what do you find? Do you find the salt particles settling at the bottom? Do you find? Or do you see the sugar particles settling at the bottom? No, it does not happen. This means it is stable. Means once the solution is formed, They do not settle down at the bottom even if they are kept undisturbed for a certain duration of time. This means it is stable in nature, right? So that is why I have written here, a solution is stable in nature. The solute particles cannot be distinguished from the solvent particles even under a microscope. This is very, very important in case of true solution. After preparing a salt solution or a sugar solution, if you take it in a glass slide and examine under the microscope and try to find out the salt particles or sugar particles separately from water particles, you cannot do so. So this will always happen in case of true solution. You cannot identify the constituent particles separately, right? Next, a solution is homogeneous. Yes, once you prepare salt solution or sugar solution, then whether you take 1 spoon from the top, from the surface, you taste it, it will be salty or sweet, whatever it is. Even if you take 1 spoon from the middle portion of the solution, it will have the same taste, either means same salt or same sweetness is there, same saltiness is there. Or even if you take from the end 1 spoon, you will have the same saltiness, same sweetness, which means the property is evenly distributed throughout the entire mass of the solution. So that means a solution, means a true solution or a solution is homogeneous in nature. Next, the components of a solution cannot be separated by filtration. Now, after preparing sugar solution or salt solution, if you pass the solution through a filter paper, do you get back the salt particles or the sugar particles as a residue in the filter paper? Definitely not. So this will never happen. If you think that by straining off or by filtering this sugar solution or salt solution, you can get back the salt or get back the sugar from the solution, only water will pass through. No, it will never happen. Why it will never happen? Because the salt or sugar particle, they enter the space, the intermolecular space between the water particles. That is why you will find that after salt or sugar gets dissolved in water, there is no increase in volume of water. So where does the sugar and salt go? Actually, the tiny particles of salt and sugar enter the intermolecular space present in water molecules, between the water molecules, and hence there is no change in the volume of the solution. And lastly, the size of particles of solute in a solution is of the order of 10 to the power minus 8 centimeter. So this is the diameter of the particles. What particles? Generally the solute particles is of the order of 10 to the power minus 8 centimeters. So you can understand 10 to the power 8 centimeters means 1 centimeter divided by so you can understand in 1 centimeter, which is from say here to here, if this is 1 centimeter distance, if this is divided into 100 million parts, 100 million parts, then that one part is the size of the diameter of a particle in case of a true solution. Okay, children? Okay, children, so thank you for today. We will continue tomorrow. Thank you.